is we want a hypotenuse length of 1 unit. How do I make a 2 a 1? By dividing it by 2. Divide everything by 2. What's 1 divided by 2? 1/2. What's root 3 over 2? Root 3 over 2. Same thing. Okay? How do I make this thing a 1? Divide it by root 2. Root 2 over root 2 is 1. Okay? 1 over root 2, if we simplify that, rationalize the denominator, that's what we get. Get rid of that, divide it by 1/2, it becomes a 1. So that's 1/2, that's root 3 over 2. Okay? And like I said, this is the same triangle as that. Okay? If it's a right angle triangle and one of them's 30 degrees, the other one has to be 60. It's the same triangle. So you don't even need to really know that. This you need to know how to do in grade 12, but like I've said several times, the better you get it now, the easier it's going to be then. Okay? Because then you move away from degrees. This would be like everything we've done would be like a day and a half. Then you move into radians. Okay? And you got angles like that, and pi over 4, pi over 6. Okay? So this is what we want to do, because we want, if this is a unit circle, we want a radius of 1. Okay? So we are here, creating the unit circle. These are the same triangles. All the hypotenuses are 1. Okay? So I'm not going to make you memorize this, because like I say, sometimes people, oh my God, at the last minute I didn't memorize it, and then, you end up, cheating. So, but what I can do is give you these triangles, okay? Or let you write them on your first page formula sheet. All right? And on the final, I'll have a formula sheet for you. You're not going to bring your book in, okay? And these guys will be on there, okay? So, what is this, though? Well, let's look at it here. Okay, in this diagram below, well, what do they want us to know? Write the lengths of the horizontal and vertical line segments indicated. That's these guys. Okay, so first, look at this triangle. There's the 30-degree one. Where is that in our picture? Right here. Okay, that's 30 degrees. What's the height? 1/2. Okay, that's 1/2. What's this distance here? Root 3 over 2. That's the big one, right? From here to here. Okay? So all we're doing here is just kind of matching it up. 45 degrees. The height is root 2 over 2. And so is the horizontal distance. Root 2 over 2, right? That corresponds to this height here. Actually, it looks like it's a little off. Okay? So that's root 2 over 2. So is that one. And what is the height of the 60-degree angle? Let's color that one. Okay, here's a 60-degree angle. The height is root 3 over 2. Okay? Same as the length of the 30-degree, because that's the same triangle, remember? Write the coordinates of these points. There's coordinates. What's the x-coordinate? It's right here. That was root 3 over 2. What's the height? What's the y-coordinate? That's 1/2. Okay, so you can think of that as coordinates of that point. We've done this already. 45 degrees. What's the x-coordinate? Root 2 over 2. That's this distance here. All right, we've got it. What's the height? What's the y-coordinate? Root 2 over 2. Lastly, what's the x-coordinate for the 60-degree? That's the same as this, isn't it? It's right here. It's 1/2. They already got that in for us. What's the y-coordinate? What's the height here? root 3 over 2. And I forgot 0. Okay, what's the coordinates of this point? Well, again, this is a radius. It doesn't matter where I draw it. If I just draw it right there, that's 1. What's the y coordinate? No height, 0. Also right at the top, where do I go for y? 0. X, that's just 1. That's the radius. Okay, so this is the first quadrant of the unit circle. Here's the whole thing. Okay, we just did this. How do those coordinates change if we go into quadrant 2? All the x's now become negative. That's it. Look, they're all exactly the same exact values, except all the x's are negative. If we move down to quadrant 3, they're both negative. Over in quadrant 4, x is positive, y is negative. Okay? So they're all the same values. These are, again, our special triangles. There's a 30-degree triangle, 60-degree triangle, that's the same. There's our 45-degree triangle, and then we just have what happens at 0 and 90. Okay? So this is another way where we can do some of our questions. You can just look on this unit triangle instead of figuring it out each time. Okay, I got some angle, 150 degrees, that's my rotation angle. 150, there it is, right? In that quadrant is cosine positive or negative? It's negative. What's the exact value there? Well, you can do all that, or look right there. There it is. Because on a unit circle, remember these? 7 yellow rabbits. What's r on a unit circle? What's my radius here? What was my radius? Why did I want these triangles with a 1 and a hypotenuse? In every case, this is just 1. Okay? So sine theta is y over 1. So sine theta is just y. So my y coordinate is just sine theta. That's what that says. Also, cosine is x over r. What's x over 1? Just x. Okay? Important, important, important. Because when I say what are the coordinates, x, y, you could just say cosine theta, sine theta. Okay, that's worth writing. Coordinates are always bracket x comma y. So what's x? It's cosine theta comma sine theta. Okay, that's what this says. Every point on a unit circle, radius has to be 1, right? Or this isn't going to work. The coordinates can be written as cosine theta, sine theta. Every point here, look at the coordinates, right? X is cosine 45, which is root 2 over 2. Sine is sine 45, or y is sine 45, root 2 over 2, okay? For those special points. And tan, like I said, we said it before, let's say it again. Because there's no tangent on this circle. Everything's in coordinates, which is cosine theta, sine theta. There's no tangent. But we can still figure it out because it's the ratio of sine over cosine, right? Because tangent is y over x, but y is sine theta, and x is cos theta. So tangent is just sine theta over cos theta. Okay? And don't worry about cotangent. That's just the reciprocal of tangent. We don't need to worry about that. Okay? Any questions? Unit circle. So this assignment, again, we've done this already, but now instead of figuring it out, just look. You can just go back and flip and look on there. Use the unit circle to find the exact value of the trig ratios for a rotation angle of 240 degrees. What would we do before? We would go 240, find the reference angle. Is sign positive or negative down there? Okay, you know what? 240. Where's 240? Down here. What is sine theta? Sine theta is y. What's the y coordinate for 240? Negative root 3 over 2. Okay? Piece of cake. Okay? Cos 240. Well, what's another way of saying the cosine of theta? That is the x coordinate. Here's 240. What's the x coordinate? Negative a half. Okay? Now, tan 240. If we didn't know today's lesson, we would go 240, right? Find out, is tangent positive or negative in quadrant 3? It's positive. Okay, 240, what's the reference angle? 60 degrees. Tan 60, oh yeah, that's root 3. Okay, because I got it memorized. But we don't want to do that. We want to use the unit circle. Tan is sine theta over cos theta. So that's minus root 3 over 2 over minus 1/2. How do I simplify that? Okay, I'll do it both ways. Big kid way would be, how do I make this a 1? How do I get rid of negative a half? What can I multiply this so that it becomes 1? Negative 2 times negative a half is positive 1. And then I won't have a denominator anymore. But I can't just do that. I have to multiply the top by the same thing. Okay? So that's just 1, which means I can just forget about it. And negative times a negative is a positive. What's 2 divided by 2? That's just root 3. See, that's the big kid way, but like I said, if this was grade 8, you don't be doing this, but I don't want to divide that, right? You never want to divide fractions. You want to multiply it. Okay? Positive 2 root 3 over 2 times 1, and we get the same thing. Either way is fine. Okay? Use the unit circle to find the exact value of cos 135. Where's 135 on my unit circle? Here he is. What was cosine? X coordinate or y coordinate? Cosine is the x coordinate. That's always first, right? That's in terms x, y. So negative root 2 over 2. Okay? Piece of cake, right? Tan 120. All right, well, I don't know tangent, but I know that's the same as sine 120 over cos 120. What's the sine of 120? Sine is my y coordinate. Over cosine is my x coordinate minus a half. Okay. Times it both by negative 2. That's gone. And that's negative. 2's cancel out. Negative root 3. That one might have been easier doing it the old way, right? What's the reference angle? In quadrant 2, tangent's negative. Reference angle 60 degrees. Look up tan 60, root 3. Okay? How's this one different? A and B are 2 points. These are coordinates. That's x, y. Okay? Where is that? You just got to find it on your unit circle. If an well, let's read the question. If an object rotates from point A to point B, how many degrees has it rotated? How many degrees is that if it goes counterclockwise? Well, what is this point? Where is it? Let's have a look. Where do we have negative, positive? What quadrant would I be looking in? Yeah. And where is it? What is that? Oh, there it is. That's 135 degrees. That's where point A is, at 135 degrees. Okay? That's A, right? That's the coordinate, so that's where it is. Where is that? If you go negative, negative, what quadrant are you in? So what was I looking at? Root 3 over 2. Down here. There's the coordinates. That's where point B is, 240 degrees. Okay? So if I move from here counterclockwise to here, then I'm going in that direction. All they want to know is how many degrees is this? What's 240 minus 135? 105 degrees. Okay? Do we see how this question would be different if I said if we went clockwise? Then I would want that, which obviously is a different answer, right? Okay, so we're just playing around with this unit circle. We might give you the degrees, we might give you the radians, okay? Use a calculator to 4 decimal places the coordinates of the point on the unit circle that corresponds to a rotation of 148 degrees. That's over here somewhere. This question's a lot easier than you think it is. How else can I write coordinates? What do I know I can write x as? This could also be written as what? Yeah. X is cosine theta. Y is sine theta. Whoop. Blew right by it. Okay. X can also be written cosine theta. Y is sine theta. Those are the coordinates. What's theta? It's 148. Okay. Put that in your calculator. Get a decimal to 4 spots. And that will tell you minus 8480. This will tell you decimal 5299. There's the coordinates to 4 decimal places. Okay? In quadrant 2, does it go negative then positive? Yes, it does. Okay? Should always kind of visually check, does it make sense? Let's ask the same question the other way. Now we're going to give you 2 coordinates. Okay? What is theta? You know what quadrant this is in? Where do you go negative then positive? Quadrant 2. There's point T, right there. Some rotation angle. Okay, what is theta? Well, this, in this quadrant, I know cosine of theta is this, and I know cosine is negative in this quadrant, so what's my reference angle? This one I'll do. Okay, take the inverse of the positive. Remember, that's how we get our reference angle. Second function, cosine. If you don't know the angle, hit the second function button. And that is 28 degrees. Okay, that's my reference angle. 28 degrees. So what is theta? Okay, made by the positive x-axis and the line passing through T. Why do they word it this way? I don't know. Why didn't they just say find the rotation angle? Okay, that's what we want to know. If that's 28, then my rotation angle is what? 152. Okay? So, like, it's the opposite of this question, right? Here we got the angle, you want the coordinates. Here we gave the coordinates, we want the angle. Okay, that's almost it. I really, really like these questions. Okay, the only problem is they didn't give us any in the assignment. I don't know why. Okay, these are fabulous. Just remember from the last day, that's the same as this. That's all I want to point out. Okay, find where that is as an exact value, square it. If you want to check, that's 1. Okay, I'm not even going to, well, here it says use the chart or the unit circle. Oh, let's just do this one just for practice, okay? Cosine 300, let's do it without the chart. Let's do it the old school way, just because we're having a quiz on this tomorrow. Okay, 300 degrees. Past 270, it's over here. What's my reference angle? That must be 60, right? Okay, that's the same as, is cosine positive or negative here? That's positive cosine 60, okay? And exactly what is cosine 60? 1/2. Sine, we've got to plus that to 330. Well, that's not 300. Let's just make that 330. What's my reference angle now? 30. Is sine positive or negative in quadrant 4? It's, let's do this, just in case some people are going, whoa. Cosine's positive here, so sine is negative, okay? So plus negative, and for 30 degrees, that is 1/2. What's 1/2 and minus 1/2? Nothing. Yep, okay? So again, these are fabulous, but, you know, they don't give us any to practice. So this really isn't new, it's just a different way of doing it. You can just look on the unit circle. Okay, for tomorrow's quiz, we can write this down if you want, okay, your little table, your chart. Okay, but test, I'll just give you these. All right, if you want to write that down, feel free. Okay, for the quiz, 2-3 questions tomorrow, quiz. All right, so yesterday, well not yesterday, last day was 1 to 5. Today, 6 to 12, 16, just A to F is enough. There's lots of zeros and ones there. And 17, 18.